Hi, welcome to this Open Security Summit session in September 2022. And we have Francesco, which is gonna take us into another world of ideas around CVEs and cloud and risk and all the things that he's involved in. So over to you.
Brilliant, thank you, Dennis. So I'm gonna take everybody on a journey on an interesting kind of path that we've taken before and all the learning that we've done. But as you know, I'm a data guy, as some of you know, I'm a data guy. So I'm gonna cut the chase and give you the answer, but also give you the data to actually form an opinion on why we think that severity and CVE has done a good job, but is now a land of broken dream. And a lot of organizations, included the one that I've been leading, have relied heavily on the concept of severity. A severity, CVE, CWSS don't tell a full story. And when you go and talk to stakeholders across the organization, as Dean is well known, and probably you also known, you look maybe some like magician or crazy person when you talk just about severity, because severity in itself is non-contextualized. And then on the other aspect that we're going to explore today is the level of automation and the level of triage and how you can apply light touch threat modeling, light touch information, open CTI that is out there to actually augment, prioritize vulnerability, to really focus on what's more important first, and then focus on risk and posture that is all about. So I hope you enjoy the show. And I have to warn you that I have a very unhealthy use of meme jokes, because security sometimes is heavy and gruesome. And if we don't laugh about it, spending a lot of time on security, we better change job. So every presentation that I do, I tend to use an extensive amount of meme. I try to not do, but let's laugh together. And as a contribution to every slide in the world and every presenter in the world, I need to put up my face, what I do, what not to do, because if you don't see my face and my pedigree, you don't trust me. Now, jokes aside, but just as a context, I used to work in a lot of organizations around cloud security, application security, being playing with data, being playing with enormous scale, and I've been playing with automation at scale. So a lot of this learning actually led into what today we call AppSec Phoenix, to help organization scale much better application security, cloud security program, and triage at scale with some level of automation. And we tend to say security is everybody's job. It's my favorite tagline, but also I add another piece. We hear more and more shift left or give developer fundamentally security concepts, but it needs to be a collaborative approach. You need to be smart, you need to be better, you need to be removing fundamentally a lot of the legwork, a lot of the useless stuff, or stuff that we can automate. I tend to call useless stuff that we can automate, because human can do better. And hence security, automation, and paved road, and posture, and risk. So what we're going to discuss today, we're going to have a walk in the park of the problem of CVE, CWE, why they don't tell a story by themselves. Then we're going to dive into a solution. Our solution is fundamentally to focus on context, risk, and the story that contextual aspect tell. We're going to dive into a series of use cases to actually prove the fact. We're going to really analyze the data that sits behind not just CVE and CVSS, but also the contextualization, the open CTI, another element that you can look and use if you want to do your own prioritization and risk. This is not just proprietary, this is not just a concept, everybody can do it. Doing it at scale is what is tend to be complicated, but all the concepts that we're going to discuss today, you can apply even manually by yourself. We're going to go through a number of use cases, and then analyzing the scale problem is the real killer of this kind of analysis and triage that we do day in and day out, and then wrap up with conclusion and recommendation. So what is the problem? What is the broken dream? Well, there is a toxic combination of factors. First factor is we don't talk risk, we don't talk security, we don't talk enough with the business, and hence we don't involve enough security with development, with the business overall. And the consequence of that is that fundamentally you have developer either not knowing about security or skipping the step if you don't have that healthy conversation, if you don't have that healthy debate and argumentation, or you don't let the business into the security decision process, and hence security ignore the process. If I'm not aware as a business, my objective is to fundamentally go forward, develop new things, and sell. On the other aspect, there is more and more CVE being declared. There is more due diligence, there is more regulation, and there is more vendors that declare CVE frequently. So we have 34% roughly more CVE year on year, every year. And then I'm going to say something that is very controversial, that everybody's going to have a debate about that number, but it's just a number. But fundamentally, a lot of the CVE that we have out there are maybe exploitable, but maybe not exploitable for your particular scenario, in your particular case. And the context is king. And we're going to talk extensively about risk, context, posture, because I want everybody to focus on just the one that matters and the one that matters first. Putting first things first and CVE first, and then focusing on all the other in a cascade, because we don't have infinite time. I wish we had infinite team and infinite time to fix vulnerability day in and day out, but we don't. So it's more important that we focus on the ones that are actually more exploitable, more targetable, rather than focusing on everything. Because when everything is a priority, nothing is a priority. And then on the consequence, on the flip side, is that if we delegate security to just security people, or security to just one developer that has done the security champion training, they burn out. They burn out and they quit. And 50% of us have considered at any point in stage of the career, this is too much. This is too much triaging. This is too much manual work. And there is not enough automation, not enough hours in the day to actually consider all the elements that form traditional threat modeling and prioritization and how to prioritize. And this is not just my opinion, it's fact that we've seen CVE, more CVE year on year. The application security and cloud security professionals are the ones that are probably more scarce because of the information and context that they need to have and knowledge that they need to have. And we have less time to fix, if you want, highly publicized or highly exploited vulnerability or highly weaponized vulnerability. I'm just gonna make the example of Apache Strat and Heartbeat. There've been others in between those two major vulnerabilities. But then in the last year, everybody has seen Log4Shell, Spring4Shell, and so on and so forth in terms of vulnerability exploited at scale. So less time, less people, more CVE, recipe for disaster if we don't automate, if we don't do this at scale, if we don't focus on the CVE that matters. And this is the data that fundamentally show that year on year, we see an uptrending of CVE and more CVE published because there is more due diligence around what's being published, but not everything gets published. And I've taken some stats just from August, and this is kind of recently in the last few days, on the number of vulnerability published just on August, and of which the one that are exploitable, the one that has public exploit, and a bit over controversial, only 10% that are actually worth taking care of because they're exploitable, because they're exposed, because they're very publicized. And this is 7 to 10% in a specific point in time, because new vulnerability get exploited at scale, then they get forgotten, then they get re-exploited at scale. So it's not a static factor. And that's the challenge that traditionally we have, that I personally have with CVE. That is a static number that is rarely changed and is rarely contextualized because it has a purpose. CVE in itself has a purpose and has served the purpose to actually declare how bad is bad, but not how bad is this particular vulnerability in your context, in this particular time, in this particular period. And this is what risk is actually meant to do. It's been misused, abused the word risk, but this is what risk is meant to do. It's meant to contextualize where you are in terms of risk position based on all the vulnerability that you have, based on all the assets that you have, your criticality. But we'll explore all this in a second. I want to reiterate, only a percentage of vulnerability are worth taking care of, and even a smaller percentage are worth taking on in your particular scenario. And I think we heavily hammered that if we try to look at every single vulnerability that is exploited for your scenario manually, that's a recipe for disaster, anybody work with. And we can't delegate this to just security because otherwise we're screwed, because there is just 1 to 50 security professional that can do this in traditional organization, and in big organization is even worse, the number and the ratio. And on the other side, we can't just simply say developer just fix vulnerability without verifying if that's happening, how it is happening, where it is happening, or how to make that a priority for them from a business perspective. And the only way to do so is actually context and risk. Context and risk are king, are the way to fundamentally translate a message that is not just how bad in potentially bad is a problem or a vulnerability, but how bad is that particular vulnerability for your environment at a specific point in time, and what is the probability of exploitation, and where it is that specific vulnerability located, and hence what is the probability that somebody can get them with level 1, level 2, or level 3 in terms of access. And that drives fundamentally two effects. That from content that is purely severity and purely unmanifested risk to actually manifested risk, or with a concept that express the risk that you have at that particular point in time, and that enables the business to make a decision to build or to fix things, and keeping it a balance, create an interesting and muscle approach to fundamentally fixing things at scale as a vulnerability management program. You develop a muscle because it's not a point in time resolution, it's a continuous resolution. But I want to discuss a little bit more in depth what actually mean this contextualization, what are the factors that it means, and why these factors. Well, if we look at a vulnerability in itself, it has an inherent severity. It has a CVE and a CVSS linked to it that express how bad it that potentially be. Now, that vulnerability in itself is not actualized, it's not deployed in a system, it's not attackable. It does have a potential, but it doesn't have a potential for you. Now, if that particular vulnerability appears in a system, then that system is in a particular state in your infrastructure. It could be externally exposed, it could be internally exposed, it could be completely shielded from, it could be even turned off in a safe somewhere. That is still the most secure way to deploy application nowadays. But jokes aside, that concept is called locality or exposure. And then you have the other factor, that is how important is that particular system where that particular vulnerability has appeared. That is what traditional business impact assessment and in a part threat modeling express as how bad that particular vulnerability, if it manifests, could potentially damage your system. So does that system has access to critical data or to private data or to PII data? What is the impact on the organization overall? And so on and so on. So how important is that system for you? And then there are another series of factors that I bucket, and I kind of put them in a bracket of probability of exploitation, that are indicator of compromise or potential compromise that you could consider in order to see if a particular vulnerability is exploitable or not. And we have a number of them. We have if there is an exploit easily accessible and available. Namely, there are tons of databases that host easily downloadable POC or proof of concept of a particular vulnerability to be exploited. Is that particular vulnerability in Metaexploit or the exploit DB that is fundamentally weaponized or easily weaponized with any of the distribution that traditionally attacker use or non-attacker use or pen tester use? And many more factors, like is that particular vulnerability exploited at scale? Is somebody in your specific industry using that particular vulnerability, or is somebody, an attacker group, exploiting that vulnerability in your industry in terms of target? So there are a number of indicators of compromise that tells you how probable is that vulnerability to be exploited, not in general, but for you in that particular context, in that particular industry. And you can go broad or narrow or very precise, considering one or many. It doesn't matter. All those factors fundamentally communicate a probability of exploitation. And there are some tools out there, some data out there that enable you to fundamentally look at probability of exploitation, or there are threat intelligence that you can buy, or threat intelligence that we produce in collaboration with FIRST that can be used.
Francesco, can I just ask you a question?
Sure.
Isn't one of the gaps that we also have is that a lot of sometimes the indicators that we have, the vulnerability, come from almost, say, very simple static analysis views, where we almost look, do we have the thing? Is it there? Is there a package? Where, you know, I still don't feel that we get enough context sometimes on the vulnerability in a way that a scanner can even go, this vulnerability, although it exists in the code, is not currently connected, versus this vulnerability is actually wired up to this service, who then wired to that service, because those are the killer ones, right? That's the ones we really want to know. And you are so spot on that context is absolutely critical, right?
Yeah, and that's the other challenge, that traditionally we had, for some reason, vulnerability management has been seen as two major branches of vulnerability management: in container, in infrastructure, and then there is another kind of population of application security professionals that look at pure software, but it doesn't look at software manifested on a server running. And the two things are disconnected right now, and it's particularly bad, especially for developer in this particular context, if they are developing in a system that is completely shielded. So tracing as well an artifact, a software artifact, and when it's getting built and when it's getting deployed has a different posture of that software artifact in the various life stages. So spot on, Denise, software and where it is related and where it is actually manifested and all the vulnerability that get carried on. It's very important for the traditional OSS operation security for infrastructure vulnerability, but it's even more important to prioritize the million of vulnerability that you can get from a software perspective. Now, there are two schools of thought, that is, fix all the vulnerability as soon as they appear, and I think I subscribe partially to that, because fixing a vulnerability as soon as it manifests in the code or in a library or in whatever you're building from a software perspective, it's faster than then retrospectively looking at the library and remembering, what did I build 4 weeks ago and how do I fix this without breaking all the dependencies in the code? So if you're an organization that is small enough that can block everything, a pipeline perspective, and fixing everything from a software perspective right now, that's great. But you still have a whole backlog of new things that pops up during the life cycle of a software artifact, because it's not static. So new vulnerability pops up in library, open source library, modified, but all those vulnerability get manifested based on where that software runs. And having the link, the contextual links, that's why I hammer on context, is particularly critical for even monitoring your life cycle or your asset register of your software asset. So some of the factors that EPSS and we consider in terms of what forms the probability of exploitation, what forms the contextualization are those, and they are fundamentally weighted in terms of how many appears and they get used. And if you don't have explore EPSS, have a look at the model. Is a collaboration with FIRST and a number of open source community that look at fundamentally feeding data on what we see in the wild, we honing it with probability of exploitation, with things that are getting hit. And then we all have created a model that inject a number of factors and look at a number of factors. And then based on that determines a number that is how probable is that vulnerability to get exploited. and it's time, so age of vulnerability, if you can see here and there, is particular vendors. If it's the code get executed, the code execution is of course king, because if we see hit rate on a particular vulnerability, that means that there are people that are actually looking at it. Now, are those people in your industry? That's even a more sophisticated way to look at CTI. Is there a vulnerability that is easily exploitable? And the vulnerability that is easily exploitable, is that present on the meta exploit? So is it easily usable by everybody across the board? Or we've seen a trending of new vulnerability and POC not anymore present in meta exploit, but in GitHub and in other source of repository. So looking at multiple factors has been particularly critical. And based on statistical analysis of what are the vulnerability more exploited from an application security prospect, this was particularly input from Veracode and other software vendors. We've seen that particular tags or particular attributes of a vulnerability like SQL injection or XSS, those are the ones that create more damage and are the ones that are more probable to get used, because fundamentally go and drive remote code exploitation or the sequence chain of attack and event. We can explore that, we can geek out on the data, because I'm a geek on data and what are the factors that forms fundamentally probability of exploitation. But what I'd like to take you is on a journey on exactly what Dennis was saying, how to manifest and what are the various scenarios of manifestation of a vulnerability. So for this particular context, we'll take two kind of scenario of the very famous Log4j. Log4j is a very common library issues or a particular module in a library that has been heavily exploited in the world. We're not going to go in full retrospective on Log4j, but just to mention, it's an easy to exploit, because with a string injection, you can fundamentally trigger a remote code execution. Now, because of that, fundamentally, the position of where that Log4j that is embedded in the Apache web server and a number of other Java-based application, the location of where that library manifests is particularly important. And a vulnerability is more external, it's more at risk than a vulnerability that is more internal. Now, if we take the journey of, and I apologize if the slide is a little bit noisy, but I'll take you to the various stage. So the blue line in the diagram is actually the stage of EPSS information and the probability of exploitation in various landscape based on events. And as you see, the probability of exploitation changes based on when the vulnerability get published, when an exploit get added in meta exploit and in different other resources, or then when it gets quiet, or then when it gets referenced and people are actually using it. So the vulnerability in itself changes and the probability in itself changes, while fundamentally from a severity perspective, that vulnerability has always remained a particular number, maybe change a couple of times, but the severity and the CVSS factors never change in time. Now, if we layer on top of that just the probability of exploitation, and if a vulnerability manifests in an internal exposed server or an external exposed server, you see how the probability of exploitation then changes when it gets bumped fundamentally 30% if a vulnerability gets more exposed with a cap at 100%, of course, if the server that hosts the Log4j is exposed over the web or maybe more internally exposed, because that information tells you how easy or non-easy is to access directly that URL, that API, that string to actually exploit Log4j. And doing this manually is absolutely impossible or very difficult to. And every single scenario that we've gone through, I spent at least a couple of hours researching and looking at the data. And if we need to do this at scale with 100 releases per day, it's really hard to do this at scale. And as a security professional, we better use our time to actually think contextually and think upgrade another strategic operation rather than triaging day in and day out, because machine can do that. We have the data, we can leverage the data, we can leverage assets and location context. So why not to? But traditionally, we have relied on pure manual labor or intense noggy or brain labor to actually do this. Now, the scenario for Log4j was quite clear. And we all know that Log4j is bad. We need to fix it. If it's externally facing, internally facing, it doesn't really matter. The board have said fix Log4j. Now, if we compare Log4j with another vulnerability, this is a CVE that was affecting a Linux kernel that could potentially take down either the kernel system or DDoS, potentially a number of series of libraries. It's not important in itself. I just want to show that from a CVSS perspective, this was a 4.7. So it was quite low compared to the CVE of Log4j, that is an 8.1. So two very different vulnerabilities, two very different ratings from unmanifested fundamentally vulnerability. Now, if we take fundamentally those two vulnerabilities in a server that is externally exposed, of course, Log4j will win forever. But also you can see that the vulnerability from the Linux vulnerability, I'm going to call it Linux vulnerability, is manifesting with a higher rating because the system is exposed. But in this particular scenario, it's quite straightforward to evaluate which vulnerability to fix first. Now, the situation slightly changed, assuming that the server that sits behind that Linux server is actually shielded, is not directly accessible from the web. But you can see the vulnerability from a Log4j perspective get dumped down, while the Linux vulnerability remains there and is more easily exploited, not considering all the factors, but just locality and where that particular library, particular vulnerability get manifested is more easily exploited there. So we're going to go through a number of scenarios where we consider some of the factors in conjunction and in a sequence. Now, if we take the scenario of criticality, and if we take two systems, we're going to take fundamentally just Log4j for the purpose of this discussion, and locality, so where those Log4j manifest, and how important are the systems. So on the left, on scenario one, you have systems that are low priority. They have public data or maybe just slightly non-public data. They're not revenue generating. While on the right, you have a system or a series of systems that are more crown jewel. They have PII data. They have more critical data. They actually might be revenue generating for the system, for the organization. Now, if we consider Log4j in atomicity, Log4j in itself is just 8.1 from a CVSS perspective. If we consider Log4j in internal, it has a 6.48 score. And these scores are actually just a reference score to actually just communicate where it is from a vulnerability perspective and how it changed in terms of risk perspective. If you consider fundamentally the Log4j, in an internal system, but in a critical system, fundamentally, it gets translated into a higher risk level compared to a system that it has non-production ready data or public access data, or is not business critical in terms of revenue generating or impacting. So all these factors actually tells you a very important story for you as a security professional and as a business to actually consider where we focus first. And CVSS in itself would have been 8.1 in two kind of location, they will be equal overall. Now, if we change and if we add complexity when you need to choose between two vulnerabilities to solve on two different systems, we can see them from the previous example, the Linux vulnerability and the Log4j manifest in a different way and get dampened down in a different way if the system are internally facing or externally facing and is low priority or low criticality. Now, if we take the same example on high criticality, now the situation change and the one that is more external get bumped up, but also the Log4j get bumped up additionally. Now, these two actually are chained up together. So a chain of vulnerability could get attacking one and the other in a sequence or take down the system in a sequence. So there is also a ripple effect or the blast radius effect that influence the two vulnerability. And we can spend a ton of time now debating and discussing what are the other factors. But this is a clear cut and a clear division that tells you risk with all these factors contextualizing and actualizing tells you a story of what to focus first and which vulnerability to focus first that CVSS in itself doesn't.
So Francesco, this is pretty awesome, right? I really like the way you're presenting this because it's a great way to understand the context. Have you seen a schema to represent this in a kind of a JSON or graph format?
Yes, those are metadata fundamentally. Those are all flags and metadata and keys to that you can calculate the risk, and you can decide this as a weight of this factor, this is a weight of this other factor. You can generate your own risk formula based on this information. It's gathering this information that traditionally is complex and gathering the asset registry and the software asset and where they are deployed, and hooking up all these together with the threat intel, live locality, and doing this at scale so that it's not manually setting by using fundamental tags or tag base from an AWS perspective, for example, or other things. That's the challenging part. That's fundamentally what is challenging in traditional organization.
Yeah, absolutely. And it'd be amazing to start linking also this to threat models, right? Because fundamentally,
yeah, but this is fundamentally threat model or a light touch threat model, because fundamentally the criticality is a number, is an output of threat model. So you can consider PII and data access, or you can consider user impact, or you can consider revenue generating. We have up to 10 factors that we're actually asking in terms of light touch threat modeling on a system, and the threat modeling get applied to the system in itself. It's not something that manifests in a specific server. You can even explode it and be more granular and saying, okay, this server is not accessible. This server has direct access to PII. So you can go as granular as you want. But the whole key concept of this is to programmatically and systematically applying this concept so that it gets really quick to decide. It's time to decision on the vulnerability that matters most, the 10% of vulnerability that needs to be fixed immediately. And then you can spend the time to actually review the others, because the probability of exploitation decrease systematically. Now, this is particularly, if you want, straightforward to explain for the vulnerability that actuate in the various locations. Now, if we take the complexity even a step further, we have other categories of fundamentally issue of keys fundamentally in code, or other kind of element of misconfiguration from a code perspective, as Dennis, you were saying, and tracking them into deployment and deciding between vulnerability in software, vulnerability on a system, vulnerability on a container, vulnerability on code, which one should we do, and should we prioritize? We all know that keys in code equal very bad thing to do, and there is some level of automation in GitHub and in a number of processes that now enable you to detect or even not gate it overall. So as a practice is really bad, but if you have tons of them in Log4j, which one should you prioritize? If your particular code is affecting a particular system that is critical, absolutely that first, because that gives a door and an access to your system that shouldn't be there, and potential ripple effect. So in general practice, key in code should be prioritized overall. But if the system is actually just a public system that doesn't have particular ripple effect, and you have another critical system that have a particular ripple effect on the organization as a whole and could be taken down, that's a debate to be had, and which one should you fix for, the Log4j on a critical system that is live and is revenue generating, or a key in code. And it's all a matter of priority. Now, if we layer on top of that as well additional complexity and additional issue from a cloud perspective, a misconfiguration in cloud, again, is contextual. Is where it manifests, is what kind of data it has. AWS will flag you an exposed S3 bucket as bad overall. But if the S3 bucket needs to be used to actually expose data or a report for your server, for your system, that's almost a false positive, or that's considered a false positive because it's a known effect. Overall, it's bad, but it depends on the kind of data, and it depends on your posture and what you would like that system to do. And finally, the final element is container, because we all run on Docker container, we all wrap things in container, and container in itself have library issue and container issue because they're fundamentally operating system and they have vulnerability. Now, if we wrap everything together, The challenge is which bed is bad and which bed is better or better to fix first. And this is all the whole idea and context of vulnerability and how it should travel in a journey of vulnerability.
Actually,
now, I would like,
can you just go back to that one?
Yeah.
There is the previous slide. There's another element here, which is also the mitigation controls. So for example, like if you have a WAF in front, of that is able to successfully block that, not I say that it's, it's like if you look at this, right? If you look at all of this, and this is where I think sometimes worldly maps could be really interesting, right? Again, to give even another layer of context, right? Is, for example, which one of these can be protected with a WAF, or something on a network? Which one of these, when they get exploited, right, they are very easy to detect, because that's a very interesting metric, right? Like the easy of detection, or let's say your ability from your network monitoring tools or your logging tools to detect exploitability are also, a very important signal, because if you have all this, and I told you one of them we can detect very well, and then there's a spectrum of them, one of them we have no ability to detect it, you probably want to start with the one that you can detect, because the sort of the damage that can be done is much greater, right, than the one that you can detect. At least you can put a plan to say, look, we'll just shut it down, right? At least you can do something about it if exploitation starts to occur.
And I think that's key. So compensating control have another consequence, that you need to have a concept. From an architectural perspective, you see things linked together, but from a system perspective, they're not linked together. So compensating control actuate or dampen down fundamentally the probability of exploitation of certain risk or certain vulnerability if they're placed in a specific system in a specific way, but also tracking them programmatically, it tends to be a challenge. As you rightfully say, if you are the WAF in front of an elastic load balancer in AWS, that dampens down fundamentally the probability of exploitation of log4j for that particular set of system. If you deploy the string correctly, that's a different story of the positioning and of the correctness of specific compensating control. But that gets into a philosophical debate. But if we take that example, it's difficult to trace nowadays what are all the systems that sits behind that WAF, and you need to have a very good, clear asset register of things interconnected together. That's why I stress the fact that context is king, because you have that knowledge of how things are programmatically built together and what are all the metadata that, from a security perspective, you consider when you evaluate risk. That in itself is just a dampener of fundamentally a number of risks across the board. Now, very good question, Dennis. I would like to also take a very old vulnerability and the evolution and the journey of that vulnerability over time, because it's a narrative and a story to tell fundamentally when you consider how a vulnerability particularly evolved. So this particular exploit was first seen, this was actually data from Mandiant and the traceability and the trace that they've done on this particular vulnerability. So this particular vulnerability was first seen exploited in the wild, but few threat actors on the 29th. On the 2nd of December, that vulnerability got registered as a CVSS. This particular vulnerability is a flash player vulnerability. We don't have flash play anymore, thank God, or very rare occasion, but it was a particularly dangerous vulnerability to exploit in the wild. So it was registered as a 9.8 from a CVSS score, and that stayed 9.8 forever. So if it's there and it happened, is that vulnerability. On the 3rd of December, that vulnerability got disclosed, the patch was released, and fundamentally, because the patch was released, the vulnerability should have been decreased or dampened down and then increase again because the POC was released and a couple of threat actors started using this at scale. The meta-exploit kit was deployed. So if you consider the risk scoring and how that evolves, it evolves in line with the probability of exploitation because a number of indicators of compromise appears in the wild. But then all of a sudden, we don't see that vulnerability exploit in the wild anymore, so it decreased a little while. Then we see APT 37, that is a North Korean group that exploited in the wild, and hence the vulnerability get bumped up, and then it gradually decreased to a 7 because we don't see that manifested overall. So the probability of exploitation actually changed the way we consider a risk of a vulnerability appearing based on the context where you are, and then events get bumped up to a specific percentage, or it depends how many times it get exploited. So again, this is to make the case that CVSS and CVE information are great to a first screening of vulnerability, but then you need to contextualize and manifest them in the wild and with the probability of exploitation. So again, context is king, risk is even better. And the factors that I would like to consider are the following. So this is fundamentally a scheme and a factor that consider all the vulnerabilities that are out there, and how to prioritize and deprioritize, and what are the factors that goes in the two kind of major components. That is severity, this is how bad it is, impact, how bad it is for you, and exploitability. It is a combination of factors that we consider as an organization that determine how frequently or how probable is that vulnerability getting exploited. That is context, so locality, so where that vulnerability appears, Twitter chatter or chatter overall, and public CTI like EPSS and other kind of cyber threat intelligence, an indicator of compromise that we combine as a metadata to form fundamentally an exploitability factor that is a number from 0 to 100, or in our particular case, from 0.1 to 1. And there are a number of data and resources to fundamentally consider, like Twitter scoring and Twitter rate gives you the probability of exploitation, or the Twitter chatter together with the EPSS score and the percentile or the probability of exploitation of a particular vulnerability based on the data and the model. So the impact and information that you have out there can be used to triage and drive a lot of these decision points. But again, hooking them up all together at scale is what is traditionally challenged. And you can do the same exact kind of modeling, and this is from Veracode, one of the reports from Veracode, where you look at the probability of exploitation of the vulnerability from a code perspective that are deployed, and they are happening more frequently. And those are the factors that also comes into EPSS and other kind of data modeling, because certain vulnerability from a code perspective get exploited more. But again, you need to manifest them. Now, we all can agree that this is great, but the tool that we use to fundamentally detect vulnerabilities are split. And again, Amin, I apologize for that. If you have ever been a CISO, if you have ever gone out to shopping for a tool, you get scared, because there are very specialized tools in cybersecurity that focus on different areas, and especially in operational security, or how you build things and where you deploy, you get an enormous amount of tools that do and specialize in specific things, and hooking up and tying up all this information together in a rational way traditionally gets into the hand of security professional to triage and use it if we don't leverage this as data. And if we hook this one all up together, it's particularly challenging to then consider the exploitability score from vulnerability coming from different data sources and where they manifest in a contextual ways. And is a dream to actually hope that any developer that have a very split second time to actually decide what to fix and what to build can make a decision across the full stack. And right now, this is what we ask in developer by saying security is shift left, is developer responsibility, without helping them to giving context and helping them to prioritize what matters most. Because 90% of the time, or actually 70%, as we mentioned at the beginning of the presentation, is going to be by chance. And hooking or looking at the vulnerability that probably last time it got reported or last time it got hit in your backlog. So it's first in, first luck, first serve. Sorry for the play on word. So the second answer is automation at scale, and risk fundamentally at scale, and it's hooking up fundamentally what you build, that is your software pipeline, where you build it, and then enrich it with probability of exploitation or threat intelligence, an indicator of compromise, and business context. What that gives you is risk, a risk expectation. And with risk expectation, you can set target that then will drive actions. Or you can set a number of actions based on target to actually hit that specific target. So what this model does is fundamentally help orchestrating an organization overall and help setting a target overall of how bad we want to be and we can tolerate to be, rather than moving away from pure severity. And again, I'm going to reiterate, doing this at scale is particularly challenging because the life cycle that we have to go through is particularly challenging. Is the contextualization and aggregation of all these report and vulnerability information, and then the triaging and prioritization and threat modeling that we have done it, that is step number 2, and then deciding what to fix. And in all that event and time, we probably would have been exploited at some stage or at some level, and if we're not, we're lucky probably. So that's what's happening nowadays at scale, and that's why we have so many compensating control to fundamentally give us more time and breathing space to actually go through this process, but it's getting less and less. And I'm going to quote Polemon Institute because it's a must in every presentation that have statistics. But we get more developer every day and we get less security every day. Traditionally, the scale is 1 to 100, 150 security professional to development. It changed based on the type of organization that you have and the fundamentally amount of application that you can do triage and at scale. And that, again, caveat depend on the complexity of the organization, change over time. So without automation, without threat assessment, we have a trap for security professional and we get burnout. And fundamentally, we have a story of different organizations. If you are a small organization, few security professionals that are in there, and I've seen this in the wild a lot of time, you can probably just block everything by default and have some compensating control and have the triage at scale. So this complexity actually is a decrement to your organization if you are a small and medium organization with 100, 200, maybe dev. Now, this scenario entirely changed because traditionally what happened is these startups get a very quick growth and become SME and then keep on growing. And the number of developers outrank the number of security professionals, 200 to 1 or 100 to 1, depending on how much is the budget. So the complexity and the SLA and the requirements required in this kind of right case scenario are very different from the left case scenario. So tools and technique that used and were practical to use in the left at scale with a number of changes are impossible. And the tool that a lot of organizations have used is SLA. And SLAs are a good starting point, but a terrible tool overall to fix vulnerability and vulnerability timeline because they are uncontextualized. They're just a number. SLAs are just a number that express for a specific vulnerability how long it takes to needed to be fixed. And that's traditionally not agreed as an organization specifically, and tend to just generate is a policy-based security that doesn't lead to actual security. A better way probably to do SLA and measurement and metrics are risk-based SLA if you consider all these factors, because all of a sudden you actually take into consideration not just the severity of vulnerability, but where they manifest and how bad the system is or how good the system is. And then those SLA have more meaning. But it's even better to use security OKR and to drive fundamentally team to define their own timeline to fix and to do their own triage, because you give the key and the power and you empower those teams. So I want to leave you with this, that there is hope and there is a better way. And did we fix security today? We found the solution to every problem? Probably not. But we find a better way to actually go forward and scale better security teams so that security team can then do the things that are more important. And as Dennis was saying, they can focus on systemic changes like introducing compensating control, introducing critical controls, doing threat modeling at scale, or deciding instead of fixing a tons of vulnerability, upgrading the system overall, or scrapping or rebuilding. Those are the things that security professionals are meant to do as a scalpel, and instead we're using them today as a sledgehammer. And a lot of this information is out there, a lot of the threat intelligence is out there. What is complex to do is tying this all back together, and that's what, as a startup, we are here to do, and is a very difficult job, to actually work smarter and not harder, to focus on risk, to focus on outcome and output. And we created a tool that fundamentally does that: aggregate, contextualize, triage, and help you triaging at scale and deliver fundamentally targets for every team into ticket overall, and move from a risk-based target into a selection of tools and element that a team needs to focus on based on the risk expectation of organization. We absolutely love OWASP in every organization and every community. So we have a community edition for all our OWASP users to do this at scale, because even small startups are entitled to do application security and infrastructure security at scale. So we want to help them getting better together. And as a community, we've wrote a number of publications across the board to actually help organizations getting better at security. The first collaboration that we did was all this journey application security from zero to hero. And just today, we published a new white paper on with exactly this content on contextualization and prioritization, and what are the factors that are important with all the data that you've seen in this presentation. And we also talk a lot about security, and I run a podcast where I invite thought leaders and I tell stories, and we talk security, application security, cloud security. Is called Cybersecurity and Cloud Podcast. So you can see them in www.cybercloudpodcast.com, and is sponsored by, of course, us. So I'd like to thank everybody for listening. We have few minutes for question. I know it was very dense, it was very packed, so I'll be able to share the presentation on LinkedIn if you follow us on LinkedIn.
Yeah, I'll just check the chat. I don't think there's a lot of questions there. What I really like about this is the fact that we now really start talking about scaling and talking about the complexity of what we're trying to do, right? And especially more and more, we're starting to go in talking about risk and context, which is ultimately what the business owners understand, right? They understand risk, they understand context. And a lot of times in the past, we would go, well, fix this because, right? And developers and even IT engineers and network, engineers, and execs would go, yeah, but there's only so much you can take that. And when you have so many that you want to do, I think some of the ways you're visualizing here is really, really powerful. It's really great. A great contribution. Good stuff.
No, thank you. And I think you're right. And there is only so much time we can go to the board and panic the board, or panic a stakeholder and say it's all bad, or a report is all bad, and say it's all critical, because then we becomes accustomed to everything being bad, and almost like, okay, we can live with it because nobody has exploited it today. And when it happens, then we desensitize to the term of risk. And actually that's a campaign and a pet peeve of mine, to actually drive away from the concept and term risk as it used today. A lot of the time, risk and severity are used interchangeably when they are actually not. And we tell the business the story that we have critical risk, when actually what we are telling them, we have unmanifested severity that somebody has written that are critical in a scale from a 1 to 10, but not in our particular scenario.
Yeah.
And that's why. And I think we ferociously create a context, data, and doing this at scale is actually what's challenging, and tying things up at scale is what's challenging. And there is no one solution that fits all. We have multiple solutions and heuristic to just track fundamentally how things are composed in AWS, in a lot of production. And there are multiple solutions where you need to track software assets. And all this to actually create the metadata, to create the context information, and then you can use programmatically at scale. And we're taking that even a step forward by enabling JSON-based policy to actually modifying the risk based on specific condition, so that you can, if you want, you can really alert as a SOC or as a team when things are and when events are happening. But I can geek on the data as well as you, Dennis. We can dive
the
into
other
data.
element here is that for it to scale, we also, I go back to a graph, right? We also need, for example, some of the data, that we get about vulnerabilities to be shared. It's almost like the graph that you're creating in your presentations. We need to start having schemas that allow us to get a lot more context, so that when you want to automate it, right? If you think about those touch points for automation, they are part of a bigger schema, right? And if the data that we get is already not having that level of detail, then you have a problem.
No, I totally agree. I think from a vulnerability perspective, we are getting ahead of the game, and we're making some progress about agreeing what is the standard on how we report vulnerability and how we report indicator of compromise. Each industry, unfortunately, has established their own standard, and the way we report assets from an infrastructure perspective is very different from the way cloud or each cloud environment report assets. So unfortunately, we don't have an asset register schema or initiative. I hope the Linux Foundation, wink, wink, starts one, because that would be a great initiative to even standardize the cloud security schema, because they are entirely different from each other. So what we define as a virtual machine in AWS is very different from GCP, Azure, Google Cloud, and so on and so forth. So even if we standardize on one asset domain, I'll be very happy, because we don't need to have like 2 or 3 engines just to decrypt that information.
Exactly, that's what I mean by schemas, right? So cool. I definitely feel that one panel we should do at the next one in London about schemas, because I'm also doing quite a bit of work on it. I think we get to the point where schemas are important, right, for this to scale, right, and transformation. So, and I think there's enough people now working on this problem that I think we can bring some good players in. So brilliant. No, thanks for this. There's definitely one videos I'm definitely going to tell my team, you have to watch this. Really great context, right, and really good positioning of that, right, and especially the whole, I think context is king is really the key, right? The fact that we need context to make decisions, right? I still remember these conversations with some security professor where I was saying, you don't have to patch that SQL injection, you don't have to patch that highly critical, because it doesn't matter where it is, right? It's like
it's the why, but it's the why. When you translate a story of don't patch that, the challenge is, so what? Or actually the opposite, or please patch this, and the challenge is, okay, prove me that it's exploitable. And then the security professional goes away, develop the exploit, goes there, and in the meantime the code has moved like 6 days of the trial.
Well, that too, right? But the why is quite cool, right? So I like the idea of the 6 whys or 5 whys, right? Where you keep asking why, and very quickly you either hit on a very critical, part of a risk taxonomy or NIST framework or GDPR or compliance or policy, right? It should hit one of those, right? There should be one. They go, well, because we break this, because we break data, because we have these requirements that we do. So cool. All right, man, brilliant. Thanks.
Brilliant.
Thanks for doing another session on the side, and I'll see you in the next one.
See ya. Thank you, everyone.